in order to understand the concept of integration completely, you need to master your differentiation chapter. Now, as we know that differentiation, it gives you the gradient equation of the function which you have just derivated. Right? Now, what integration does is, integration gives you the area under the graph. Right? So this is the difference between those two, area under the graph. So let's take an example. Let's say I have a VT graph, alright, velocity time graph. This is my velocity. Velocity is represented by y-axis, and this is my x-axis, which is represented by t. Now, if I derivate this graph, right, let me draw the curve. Let's say the curve is somewhat like this, right? This is our line. This is a velocity time graph. Now, this is f of x, alright. Now, if I were to derivate it, right, if I were to get its f complement of x, that will give me the gradient equation of this graph, which is equal to what? Acceleration, right? And if I make the graph of this f complement of x, I'll get the acceleration time graph of this object, right? Now, if I were to integrate it, alright, so let's say if I were to integrate it, this is the sign of the integral f of x integrated with respect to x-axis. So this will give me the displacement of this graph. Why? Because the area under this graph, the velocity time graph, from let's say this point x1 to this point x2, this area is equals to what? Displacement or distance covered, right? So integration gives us the area under the graph. So if I were to integrate this function f of x, I would get the equation for the displacement time graph of this object. Alright? So that would be somewhat like this. Alright? Displacement time graph. So this is the basic difference between differentiation and acceleration. Moreover, integration is the opposite of differentiation. Let's say if I were to integrate this acceleration, let's say if I were to integrate this acceleration function, I would get the velocity function. Alright? So it is the opposite of differentiation. Hence, differentiation is the opposite of integration. Now, if I were to derivate this displacement time graph, right? Take the derivative of this thing, d by dx, alright, let's s of x, let's name this as s of x, right? So this will give me velocity time graph. So integration and differentiation are opposites of each other. Integration gives us the area under the graph, alright, differentiation gives us the gradient equation of the graph. So that's it. That's the introduction for integration. In the next lecture, we'll learn how to integrate an expression or a function.